Question 7a, divide s squared minus 4 over s squared plus s by s squared minus 4s plus 4 over s plus 1. This is the meaning of that question. We need to change division sign to multiplication. As that is going on, you invert this fraction to this form. By difference of two squares, if you factorize this, you get this. If you factor out s from here, you get this result. This is already in simplest form. It remains the same. You factorize this term, you get this result. You cancel out common terms. S plus 1 will remove s plus 1. S minus 2 remove s minus 2. So you are left with s plus 2 in the numerator and the product of s and s minus 2 in the denominator. Question 7b. The diagram shows the graphs of y equal to as squared plus bs plus c and y equal to ms plus k, where a, b, c, m, and k are constants. Use the graphs to, remember figure 1, find the roots of the equation as squared plus bs plus c equal to ms plus k. The left hand side is the curve and the right is the line. The solution is simply the points of intersection of the curve and the line. Let us get that right away. So this is one point of intersection. This is another point of intersection. The scale on the s-axis, in fact both axes, 2 centimeters to 1 unit. That implies that one line is equal to 0.1. If you start counting from minus 1, you have it at this point, and that is minus 1.5. That is one solution. If you start counting from 1 as well, you have it at this point. That should be 1.6. So the solution is minus 1.5 or 6 or 1.6. Roman figure 2, determine the values of a, b, and c using the coordinates of points L, M, and N. Hence, write the equation of the curve. So you have this coordinate at this point when y is 0, s is minus 1. Another one is here when s is 0, y is 2. Another one is here when y is 0, s is 2. When you are doing it using coordinate, you start with the intercept on the y-axis. At this point, s is equal to 0. So if you put s equal to 0 in this equation, you have y equal to 2. That is this point. So you put y equal to 2 and s equal to 0. That gives c equal to 2. So once you get c as 2, you use the other coordinates to form two equations. You solve them simultaneously for a and b so that you can write the equation. After doing that, it becomes very easy to get the line of symmetry of the curve. Solution continue. I've already explained the answer you ought to have. So I have already answered Roman figure 1 of the question. The solution occurs at the points of intersection of the curve and the line, and you have s equal to minus 1.5 or 1.6. To find A, B, and C, you have the 3 coordinates. Like I said earlier, you can start from the y-intercept or any one precisely, but taking y-intercept will give us C. Of course, you need to replace C in the remaining equations. All right, so we have the first point there, L, when s is minus 1, y is 0. If you replace them in this equation, you have this result. So let's call it equation 1. The second coordinate, when s equal to 0, y is equal to 2. If you replace the two values in this equation, you have it in this form. And as I said earlier, c is equal to 2. The third coordinate, when s equal to 2, y is equal to 0. If you replace the two values in this equation, you have this, and that is this. Okay, so you substitute equation 2 into equation 1 and 3. That is, you want to replace c equal to 2 in equation 1 and equation 3. So if you do that, you get this equation. From equation 1, you have a minus b plus c, that is 2, equal to 0. If you transfer plus 2 to the right hand side, you have a minus b equal to minus 2. So let's call that equation 4. Then if you take equation 3 and replace c with 2, when you transfer it to the right hand side, you have this result. If you divide through by 2, you have this result. So let's call that equation 5. So solve equations 4 and 5 simultaneously using elimination method. Okay, let's check the two equations 5 and 4. We can eliminate b by adding. B has the same coefficient in both equations. So let's start by eliminating b, and you do that by adding since the signs are opposite. So if you add, you have 3a equal to minus 3. That implies a is equal to minus 1. To get b, you need to substitute a equal to minus 1 into equation 4 or equation 5. Here we have equation 4. You replace a with minus 1 minus b equal to minus 2. To make b positive, transfer it to the right hand side and transfer minus 2 to the left. It becomes plus, and b is equal to 1. So a is equal to minus 1, b is equal to 1, and c is equal to 2. So you come back to this equation and replace a, b, c with their respective values, and you have the equation that you are asked to write. Roman figure 3, the equation on the line of symmetry of the curve is obtained using this. From the previous solution, b is 1. Because b here is negative, it becomes minus 1. A is minus 1. So 2 times minus 1 becomes minus 2. That becomes 1 over 2, and you have 0.5. In other words, the equation of the line of symmetry of the curve is s equal to 0.5. Pittacus Simplified Maths. If you are watching and viewing from YouTube, don't forget to subscribe for more updates. Like and share PSM videos. If you are watching and viewing from Facebook, follow and like the page for more updates. Also share PSM videos.